Hello, geometry students. We are looking at lesson 4, distance on the coordinate plane. You should be in your workbook on page 13. All your guided notes for geometry will be in your workbook. And again, that's page 13 for lesson 4. We're starting out with the distance and the slope between 2 points. So we can do this using slope formula. So if I wanted the slope, we put change in y over change in x. And I see a y coordinate here of 0, a y coordinate here of 0. So I'm going to do 0 minus 0. I said that one first and this one second, so I'm going to go ahead and put y1 here and y2 there. These are my x's. And since I called this first point my 1's, I'm going to stick with that order. So I'm going to put 0 minus, and that number that I'm minusing is a negative 6. So 2 negatives make a positive. That makes my denominator a 6 and my numerator is a 0. If I said, hey guys, I have $0, I'm going to share it with 6 of you. You couldn't, you could divide it up, but how much money would you get if I start with 0 and I share it with 6 of you? You'd get nothing. This has a slope of 0. You can do this exact same work with the graph that's given to you. So if I look at negative 6, 0, and 0, 0, so this is my point A, this is my point B. This line has a slope of 0 because the steepness is 0. My rise as I go from A to B is nothing, but my run was 6 or negative 6, depending on my direction I went. That's why it has a slope of 0. And we can quickly see, because it's on a number line, that the distance, there's 1 square here, 2 squares, 3 squares, 4, 5, 6 squares. My distance is 6. So if I do a similar thought process, but now for BC, C is at negative 6, 4, and we already had B. If I look at this line, now I absolutely can, what am I doing? I absolutely can use my slope formula, or I can just count rise over run because it's graphed for me. So the rise, I'm going to start at C, 1, 2, 3, 4, and I went downward, so I'm going to say my rise is negative 4, my run is 0. So if I have 4 cookies and I divide that equally amongst 0 people, that's just an impossible problem. My cookies can't disappear. I can't break it into 0 groups. This is when we talk about having an undefined slope. If you talk about the steepness of your bedroom wall, that doesn't make any sense because it's going straight up in the air. Whereas the steepness of your floor makes sense because it's just flat. We can also talk about the distance. I actually already counted it. 1, 2, 3, 4. Now, yes, I'm going downward, but it doesn't make sense to be negative 4 feet away from your charger. You would just be 4 feet away from your charger. Distance is always positive. So again, we have a distance of 4 here. And we had a distance of 6 here. That's not the same color. So I had a distance of 6 here. The nice thing is we can now unlock a pretty powerful property. I'm trying to pick a color, sorry. That helps me find this distance. Now I cannot, I could count rise over run. Let me say that. Let me count rise 1, 2, 3, 4. So I went up, so that's positive, and I'm running 1, 2, 3, 4, 5, 6, and I went left. 4 and 6 both divide by 2, so I'm getting negative 2/3. You could also use slope formula for that. But the thing is, that's great for finding slope. That is not helpful for finding distance, because if it's not perfectly vertical or horizontal, counting's kind of useless to you. So instead, I want to point out that I have a right triangle. And we just spent some time going over properties of right triangles, specifically that their sides are related to each other with the Pythagorean theorem. A squared plus B squared equals C squared. So I'm going to use the legs for A and B. So A, I'm going to use for 4. So I'm going to take that 4 and I'm going to square it. For B, I'm going to use the other leg, which was the 6, and I'm going to square it. If I square those two numbers and add them up, I'm going to find what this hypotenuse length is, the actual distance of segment AC. So 4 squared plus 6 squared, well, that's 16 plus 36. 16 plus 36 is 52. So we're seeing 52 for that sum is x squared, and the opposite of squaring a number is to square root it. So I'm going to square root. Now, it says what's the distance? It doesn't say approximate distance. It doesn't say distance to the nearest tenth. So I'm not going to round this. I'm going to take that 52 and I'm going to see if I can find any pairs, because pairs make perfect squares. So I just took out some 2's because I know even numbers can divide by 2. And what I'm seeing is instead of the square root of 52, I have the square root of 2 times 2 times 13, because 13 can't break apart anymore, just like 2 cannot. And since pairs make perfect squares, the square root of 4 is actually a 2, and left over is the 13 because it didn't pair up. That's why you can't just count that distance, because most of the time you're going to get an irrational number that doesn't turn out to be a nice pretty number like 4 or 6. So that's going to be useful when we go to find some things about line segments. So that's what this next vocabulary is. The part of a line consisting of 2 endpoints and all the points in between is a line segment. So off to the side, I have an entire line drawn, but if I just want to take a chunk out of it, I want a segment of it. Basically, I want to say, okay, let's take this part all the way, let's say here, and stop here. I'm taking just a segment of the entire line. Now, when I do that, I just set a start and a stop. Those 2 locations, those 2 points, usually those 2 capital letters, will be how you name this. So that segment that I just made up is segment XY with a segment symbol on top. That is segment XY even if I throw a W in between, even if I throw a T in between, even if I throw an F in between, that entire purple segment is still segment XY. So in the previous example, I got 2 root 13, and that was from starting at A and going towards C, which means that segment's name is segment AC. The name of the segment that was 6 units long, that was from number 1, started at A and ended at B, therefore it is segment AB. Now real quick, most of the time we read left to right, so you might be thinking like, oh, I don't want to call that AB, I want to call it BA. Can I call it BA? Yes, as long as you're using the same 2 letters, BA would be counted just as correct as AB. So those are interchangeable. So this one could have been segment CA. This one could have been segment YX. As long as you say begin and end, you'll be good. So if you have 2 segments that have the same length, so maybe I found another segment that's also 2 square root 13. If they have the same length, they are called congruent. It's our fancy math word for basically saying they're equal. So if you have congruent segments, they'll be the same length, and we can be lazy and not write that out. We put an equal sign with a squiggle over the top. So I want to find the length of segment AB, and I'm telling you where A is, which is at 1, 4, and I'm telling you where B is, 13, 9. So this is the segment in question. It is not horizontal or vertical, so you can't just count it and say, oh, that's my answer, I get this nice pretty number. We're going to have to rely for this segment length on the Pythagorean theorem. The Pythagorean theorem only works once you have an entire right triangle drawn. So I'm going to use these lines, which you'll notice are a rise and a run line. The 4 and 6 were part of our slope. So I'm going to draw on those auxiliary lines and figure out some rise and run. You have 2 options. You can choose to rise first and run second, or you could choose to rise from B first and run second. It doesn't matter. It will not change your answer. What I want to point out though, this rise is 100% negative 5. If I was asking what's the slope, you would use negative 5. I'm talking about length, distance. When you talk about length and distance, you lop that negative off. Negatives don't exist when you talk about how far away things are. Likewise, when I write in my run line, it doesn't matter if I go left to right or right to left. You are still going to use a 12 here regardless. So then I get my right angle. So the legs are the 5 and the 12. So I'm going to use 5 squared plus 12 squared. and it equals the hypotenuse squared. 5 squared is 25, 12 squared is 144. When you sum 25 and 144, you get actually another perfect square. This might not be one that you recognize though. It is actually 13. So you might not notice that. But again, that 5 and that 12 came from the slope lines, which means if I was trying to figure out 5 and maybe you're quarantined at home and you don't have graph paper, I'm going to point out 5 was gotten from just taking 9 minus 4 and squaring it. This 12, this horizontal distance, was achieved from the x coordinates, from 13 minus 1 and squaring it. So we actually get a formula that means you don't have to rely on graph paper, because I know good and well that a lot of you don't have graph paper right now. What you can do is just take your y coordinates and subtract them and square them, because we'll have to square it for the Pythagorean theorem. And then also do the same thing with your x coordinates. Subtract them and square them. What you end up getting is the distance that we're looking for, that hypotenuse, squared, because I currently have x squared on this side. But the last thing we always do when we solve this is to square root. That's what's going to end up combining to make our distance formula. The distance formula is, again, y2 minus y1 squared plus x2 minus x1 squared under this colossal square root. So it is a formula. You do need to have it memorized, but honestly, there's not really any need to memorize it, because we can figure it out using Pythagorean theorem. We can remember, oh yeah, this is just the change in y, so I'm going to subtract my y's. This is the change in x, this is my run, so I'm going to subtract some x's. That's where it comes from. It's not just some made-up formula that mathematicians make you memorize. I mean, we do, but it's so that if you don't have graph paper and can't graph 13 accurately without graph paper, don't bother. Let's use the distance formula. Wow, we don't have many examples of that. I thought we had more examples. So, oh wait, why are my notes different? Oh, I can read. I lied. I want to do number 6 real quick. The distance between these points. So again, I'm not about to pull out graph paper to graph 25, 90. I'm going to, under a square root, I'm going to subtract my y's, which are a 40 and a 90. Now, I will note I put 2 minus 1 up here. Let's say I had subtracted in a different order, and I did 4 minus 9. The only difference is I would be getting a negative 5, but I still have to square that number. And what happens when you multiply a negative times a negative? You still get a positive. So the order is not super specific for this. You can subtract in any order. So most of the time, unless I'm finding slope, I don't bother writing down 2's and 1's. I like to subtract in the order that gives me positive numbers, because then I don't have to think as hard. But sometimes that's hard because I give you a negative. So maybe I'll just put down the negative 15 first, and I'll subtract the 25. Just like when you do slope, the important part is don't forget that is a minus sign, not a plus sign. The plus is here for the Pythagorean theorem. The x's and the y's get subtracted. So 90 minus 40 is a 50. Negative 15 minus 25 is negative 40. And I'm going to square that. 50 squared is 2,500. 40 squared is, negative 40 squared is positive 1,600. So if I add those together with a calculator that's turned on, I'm getting 4,100. And again, that's still under a square root. The last thing you do if you were actually using Pythagorean theorem would be to square root both sides. So under square root is 4,100. I'm going to break that apart. So somewhere I have space, which is not much of anywhere. Okay, I'm just going to come here and write tiny. So that 4,100, I'm looking for pairs, because pairs make perfect squares. I see that it ends in 0, so I'm going to take 10 out, which gets me a 2 and a 5. 410 also ends in 10, so I'm going to take another 10 out, which gets me a 2 and a 5. And 41 is prime? Question mark? Pretty sure 41's prime. I can't think of anything that divides in 41. So instead of the square root of 4100, I'm going to have the square root of 2 times 2 times 5 times 5 times 41. And since pairs make perfect squares, outside the radical will go a 2 because of the square root of 4. 5 times 5 is 25. Square root of 25 is a regular 5. And inside the radical is a 41. So when you multiply that 2 and 5, 10 square root 41 is the simplified answer. So that is our exact answer. 10 square root 41. But you'll also see it says exact and rounded. So in class, we'll definitely talk about how to use whatever calculator you have access to. But if you want to try it on your own, which you should, you can check your answer. It should be, well, I'm seeing 64 point, and then it says 031. So just a reminder, the 10th place is the 0. You look at the number after it. If that number is 5 and above, you round up. This one is not, so I'm just going to stay the same. Oops. So 64.0 would be our approximate answer. But again, we'll go over in class how to use your calculator to get those.